Now the question over here is last day where you can still cross. So what the problem says is that each day one more cell turns to water. You want to find the last day on which a walking path from the top row to the bottom row still exists. And now water only ever gets added. It will never reduce. Now, what this means, a key observation would be that water is only accumulating. If you can cross on day D, you can also cross on every day before D. And that also means that once a crossing becomes impossible, it stays impossible forever. And that's why we have included binary search over here, and we are splitting the cells into half. We are passing a mid boundary, and we are trying that we are running BFS on that mid boundary instead of doing it on every cell. Another hint on this in this question is that it's also a multi-directional multi-search BFS, which means that you don't have to start BFS from one point. Sorry, multi-source BFS is the word. It means that you don't have to start BFS from a single point. You can start from multiple points. So instead of seeding the queue with one cell, you seed it with all valid starting cells at once, and then the BFS will expand all of them simultaneously. And the hint in the question is over here that you can start from any cell in the top row and you can end it at any cell in the bottom row. And that's why it's a multi-source BFS. So now I will run you through the solution line by line. As I said, we are going to use BFS over here. So we will start by creating a grid, and we will assign it to be grid of 0 columns, and then we will multiply it by our times of row. And after that we have to mark our water. So we have a helper function which is called can cross, and in this we replay the flood, which means we take the first day entries. So the cells flooded so far, we unpack them as a pair, and then we mark it as water, which is what we are doing over here. The print statement is only for my reference because I wanted to check something. So you don't have to do this. I just want to see how it's working. And now we have our BFS, which means we are starting with marking a visited all our visited cells, which is also a grid. Then you have your queue data structure. So you are seeding the queue with every land cell in the top row. So multi-source BFS as we discussed. So for C in range, if grid of 0 C's, this is row, so your row is always the top row, which is 0, and column. So for each column you are gonna seed the queue. If it's 0, then you add it to your visited set, and then you seed the queue over here. Now you are going to go through a queue as you do in any BFS. So this is your classic BFS loop. So until your queue is empty, you will pop. And now over here is an if condition, which is basically checking that if this cell is in the bottom row, so that's where we end, right? If it's in the bottom row, literally any cell in the bottom row, which means a path exists, so we can just immediately return a true. If not, then we will just enter this for condition. So you will go through directions, up, right, left, down, and then you will have your neighboring. So for each direction you will add your R which you are popping. These are your out of bounds check, which are very important. So 4 conditions that we are checking over here. So you're out of bound checked, and if the bound check fails, we will never evaluate visited NRNC. And then we will mark it as true in our visited set, so this NRNC, and then we will append it, and at the end of this we are returning it as false. And then we have our binary search. So as we conduct a binary search, which is we have a low pointer, we have a high pointer, you start with 1 and then you go from until the length of the cells. If your low is less than high, means until your pointers cross paths, you have a mid pointer. You pass this mid as the day in the scan cross helper function, and then you set your, if this is possible, then your lower boundary will be your mid, which means your actual day, your result is on the right hand side, or else your high will be mid -1, which means your result is on the left hand side, and at the end you are just returning low, so that will be the final day.